How's it going, everybody? And welcome to another installment of YouTube's Ask Me Anything. And I wanted to cover an interesting question that came in the comment section. Excuse me. And that comment, it's a question that I normally would answer at a high level, where you give me some sort of scenario and I would proceed to answer it uh, more generally, but I was, essentially literally asked to go into the details. So let's talk about the question first, and then I'm probably gonna have to whiteboard this out a little bit, just so that we all understand where we're coming from, and then hopefully answer the question. So it's like I have some question regarding failover by means of BGP. I have some design at work which I don't understand. Can you please explain this design? Um, so one of the things that I do want to make mention of is I'm happy to attempt to try to answer questions like this and things like that, but I also would encourage anyone here that watches the video that if you're scratching your head and you're like meaning that you don't understand the reason why something is put into place, or the configuration that's in place, or why something is working the way that it is your job as an engineer, if you don't understand something, to raise your hand and be like, I don't get it, or I don't understand. And I don't know if maybe someone watching this needs to feel like need to be like pushed in that direction, but I will be honest with you, if I am the first person in the room where if I don't understand something, whether it's an acronym that is talked about, for example, SCADA was brought up in a conversation within the past week, and I'm like, SCADA, I've heard of it before, I just forget what it is and what it does and why they use it. But the customer was able to answer the question. So don't be afraid to ask questions, and you're never going to learn if you don't ask. But I will do my best to try to wrap my head around this, and we'll whiteboard it out a little bit. There is core switch connected to WAN with MPLS, and it has iBGP peering with service provider's edge router. Also, there is router which is connected to internet, and it's being used as DMVPN router, and it has iBGP peering over DMVPN cloud. So MPLS connected to core switch is primary WAN link, and DMVPN configured on router is backup WAN link. Also, there is iBGP peering between core switch and DMVPN router. Core switch has SPIs and runs EIGRP, and there's redistribution of the SPI subnets networks with EIGRP into BGP to send it to MPLS cloud. Also, core switch has EIGRP adjacency with DMVPN router. Okay. I'll try to summarize in order to not confuse you. Okay, good. Hopefully not. Core switch connected to MPLS and has iBGP peering with MPLS service provider. Router runs DMVPN and has iBGP peering over DMVPN cloud. There is iBGP peering and EIGRP adjacency between core switch and router. MPLS is used as primary and DMVPN as secondary. LAN network is connected to core switch. Redistribution config on core switch. Mutual redistribution between BGP and EIGRP, also static routes, are also redistributed into BGP. Redistribution config on router. EIGRP is redistributed into BGP. Can you please explain why iBGP between core switch and router is needed there? And what about redistribution? I don't understand why BGP to EIGRP redistribution is needed on core switch. Could you please reply to this comment during upcoming tech support Thursday? Okay, so kind of a loaded question, but I'm going to do my best to try to finagle my way through this. So this is actually the same type of questions I get when I'm talking to customers. So let's bust out the pen tool and try to understand what's going on here. So we are going to do a little bit of whiteboarding. Okay, so first and foremost, we have a core switch connected to WAN. So I'm gonna draw out SP here, and then we have internet up here. Like that. Okay, so what we have is core switch, so I'll write core here. And there is a peering to here. There's this iBGP. That's a horrible B, by the way. Okay, iBGP with the service provider, and there's also a router which is connected to the internet. So we'll say router connected to the internet. Okay, and DMBPN, I'm going to assume that this is a hub, and that there is, and they're running eBGP over DMBPN cloud. So I'll put it out here, spoke 1, and we'll do spoke 2 for simplicity. I'm going to assume that they're both connected to the internet, and there's no discussion as to what is on the remote side of the service provider for MPLS, but that's not the question. Okay, so MPLS connected, so this is your, and it's DMBPN, so MPLS, the core switch DMBPN, okay, that makes sense. Also, there is iBGP peering between core switch and DMBPN router. So there's iBGP here. Okay. Core switch SPIs and runs EIGRP, and it's redistribute the SPI networks with EIGRP into BGP to send it to MPLS cloud. Okay. So core switch connected to MPLS and has BGP with MPLS. Got it. Router runs DMBPN and eBGP peering over DMBPN. So we're going to draw a, we're going to go yellow-green here, just so we have some differentiations. We have a connection here, and we have a connection here. These are both eBGP. Okay. There is iBGP peering between peering and EIGRP adjacency between core switch and, did I miss that? Core switch. Also, there is router, which is connected to the internet. Okay, yep. MPLS router. Also, there is iBGP peering between core switch and DMBP and router. Oh, EIGRP, it's right there. Okay, so we also have, let's go ahead and change this over to sky blue. So we also have, between here and here, we also have EIGRP. Oops. Okay. So that's essentially what, based off your describing, this is how I visualize it in my head. So this is primary. Let's change this over, this color over to be green. So this is the primary, and this one here is secondary. Okay, redistribution config on core switch. Mutual redistribution between EIGRP and BGP. Okay, that makes sense. Also, static routes are redistributed to BGP. Makes sense. Redistribution config on router. EIGRP is redistributed into BGP. Okay. Okay, all that makes sense. So we have, I'm going to go back over here to orange. And so let's mutual redistribution between BGP and EIGRP. So I'm going to draw BGP here and EIGRP there. And I'm going to draw a back and forth arrow to indicate that that's mutual redistribution. Okay, and then we also have, and we're doing statics into BGP, which also makes sense. EIGRP is redistributed into BGP on router. So this is our, so we have like an imaginary line, a logical line in here, and we're doing EIGRP to BGP. here on the router. Okay. Can you please explain why iBGP between core switch and router is needed there? And what about redistribution? I don't understand why BGP to eIGRP redistribution is needed on core switch. Could you, okay. So let's take a look a little bit about how the routing table would look. So I'm going to assume here, I'm going to use orange, that I'm going to have, I'm going to put down here R1 for remote site 1 and then R2 for remote site 2. Okay, so attached to these, there's going to be LAN segments, right, of some type. This is what I'm assuming. There's parts of the network that are not thoroughly understood, so I'm going to assume some things here. So we need to understand why things are set up a certain way. So let's talk, let me stand up and we can discuss this a little bit more detail, because this is the type of stuff that you should really, if you're going to be doing any type of engineering, you should really understand. Okay, so let's talk ourselves through this. So let me just make sure I haven't missed anything. Why iBGP? Okay, so you have a couple of interesting facets to your design, which sort of makes sense, sort of don't. Okay, so you've got eBGP on your core going out to the service provider, and that's a pretty standard design. But you also, on your router, you also have eBGP going over DMBPN. Not uncommon, but it is not the, if you were to put it in like a order of operations and how best practice would go, it would go eIGRP, iBGP, then eBGP. So that is typically how I would, if I was going to go in a preferential order of the way I would do routing, I would do eIGRP, then iBGP, then eBGP. Now, there are some aspects to that make eBGP more desirable than iBGP, and we can get into that, but that's actually not your question. Your question is, and there's some uniqueness to this. So there's an iBGP peering here, and so I'm assuming these guys are running the same AS. So let's assume that this is AS 100 for the sake of argument. And we have AS, let's say 20, we have AS 10, and then we're going to do like 101, then we're going to do 102, then we're going to do 103, and then 104. So this will help us understand the AS path. So, okay, so the next thing we have to do on the core switch. So let's answer the first question, or the second question first. What about redistribution? Why, I don't understand why BGP to eIGRP redistribution is needed on core switch. Okay, so you have a BGP route, you have a local route here. So I'm just going to put an L for here because we're focusing on the service provider peerings first. You have these routes here that are going to get, and let's draw a line there. We're going to assume that these are advertised into BGP, network statement, redistribution, whatever they might be. And they get learned here up on the core. So they are going to be a BGP peering, right? So you're going to see, R1 and R2's remote sites sitting here with an AD of 20 because they're both eBGP routes. And that's probably well understood. Now, what's interesting about this is because this is your core and there's no mention of anything, any infrastructure southbound, logically, meaning there's no distribution layer switch, there's no running layer 3 routing, so all your core is doing all your routing. So there's an eIGRP peering here, there's also iBGP. So over here on the router, you're also going to have S1 and S2 routes coming across with an AD of 20 on both of those. Okay? So you have an iBGP peering set up between, and that makes a lot of sense. There's no mention of any connectivity on the remote end, behind the remote internet sites or the remote MPLS sites, having dual connectivity to each other, whether it is site 2 is dual connected to internet or service provider. So it's because of the fact that we don't have any information on that, we're going to assume that It's not there. Now we can assume if we want to, but that's not the question. Okay, so I don't understand why BGP to eIGRP redistribution is needed. Okay, so based off the information that I have available to me, why am I doing BGP to eIGRP redistribution and vice versa? So I don't know. And it doesn't make sense why it's there, because there's no indication from you that there's anything southbound of the core switch that would need to receive for you to advertise routes, or I should say redistribute routes from BGP into eIGRP. If you did, if you had something sitting southbound to here, like a distribution switch, right, and there was running an eIGRP adjacency over this link right here, then yes, that would make sense. You would redistribute BGP to eIGRP, and everybody would be happy. So unless there's more to the story that you're not telling me, or or maybe you just don't understand it, I don't know. But then that would make sense to do BGP to eIGRP, because remember, routing actually is both. For you to understand how redistribution works, the route has to be in the routing table first, then before it can be candidate for redistribution. Once it's in the routing table, then the routing protocol can then take routes from another protocol and redistribute them into itself. So, for example, if you're receiving BGP routes over the MPLS core, and now you have eBGP learned routes on your core switch, if you want to redistribute those into eIGRP, they have to be in the routing table first. So show IP route BGP, you see the remote sites subnet show up in your routing table, then you can go into eIGRP and you can type in redistribute BGP 100 and then specify the metric value, and those are going to redistribute into eIGRP. Now, so that's how essentially that would come into play. So for the sake of argument, that's not there. But that would explain why that is there, if that was the case. But that's not the case. So let's keep going. There's an eIGRP peering between the two, and there's eIGRP is redistributed into BGP. Okay, so what's probably happening here, and I'm not exactly sure why they did it the way that they did it, but technically it would work. So the first their questions are actually asked out of order. The first question here, or the first one here, should actually be a second, and the second question should be first. So we have, I'm going to reorder them so that it makes more sense for you. You have BGP to eIGRP, right, from on the core, and then you also have iBGP between the two, and then you have eIGRP redistributed into BGP, and then we have eIGRP to BGP. So what's happening here, and let's break down some of the details, is you'll receive a route in, right? You both receive the route in, but there's no mention of, oh, okay, you know what, now that I'm seeing this more, it does make sense. So what's happening, I'm sitting there trying to piece this together as I'm figuring it out. So let's talk about it from this direction here. We'll go from the remote site connections over the SP core, talk about the redistribution. So for some reason, so the iBGP peering, in order for that to work, you need to have loopback to loopback connectivity. You could do it over this directly connected link as well if you wanted to, but my assumption is somebody used eIGRP in a multifaceted reason, loopback to loopback route propagation, so that you could run iBGP. That's probably the first reason. And then there's also eIGRP is used in the core, so in the event that the iBGP peering went down for some reason, you would go back and you would ride that. But here's the thing. eIGRP for redistribution, so if you're talking about eIGRP redistributed routes, right, anything that's brought from BGP, or any routing protocol brought into eIGRP automatically has an AD of 170. What does iBGP have? That is a horrible B. I should really... What is iBGP? Well, it's 200. Right? So in this case here, they're probably using eIGRP to do the loopback to loopback peering. That's what I'm assuming is going to happen. That would be your best practice, to do loopback to loopback peering here. And they're probably since they're directly connected to each other, that is the next hop. They should, and next hop self wouldn't be necessary. So, well, you could use it still, but the routes are brought in. So then R1 routes and R2 routes would be in BGP. Then you would redistribute them to eIGRP and propagate them. So the question is, do you choose to go via eIGRP or do you choose to go via iBGP to get between the core and the router in order for site 1 to talk to site spoke 1 to talk to remote site 1? But you're going to use eIGRP, right? Because it's a lower AD. So my assumption here, based off of what I understand about routing, is that you're using the eIGRP learn path, or the route, because AD is going to win, and assuming that you don't, you're learning the same subnet from two different protocols, BGP and eIGRP. That eIGRP with the lower AD is going to propagate, and the router is going to be learning those routes via eIGRP external. So AD of 170. You're going to get those routes on the router, and then there's eIGRP is redistributed to BGP, and that is so that these sites can then be propagated into eBGP and sent over the wire. So you end up learning R1. I don't know why it does that. You learn it. This acts up on me. So you're gonna have R1 here. You'll have S. This is actually starting to irritate me now. So you'll learn R1 and R2 here will be learned via this path over here, propagated to the router, and then DMBPN will propagate over here to spoke 1 and spoke 2, and vice versa. Now here's the funny part. Based off of your explanation, spoke 1 and spoke 2 are eBGP peered to the router, but there's no mention of BGP to eIGRP redistribution. However, you're still going to learn the route on the core because of iBGP. BGP is still going to learn it, and it's going to propagate it to the core. So you're still going to learn the route. So why is that needed? Well, there's a little bit too little information here for me, but I can make a few assumptions. The assumption that I have is eIGRP is used to do the iBGP appearing between the router and the core, and that's why that is there. So the core, since it does BGP to eIGRP redistribution, is then all those subnets that are coming over the service provider are being learned on the core. BGP to redistribution into eIGRP. eIGRP propagates them to the router learns them and then propagates them or redistributes them into BGP. BGP sends them over DMVPN to the site spoke 1 and 2. Now, spoke 1 and 2 will learn R1 and R2, and you'll learn R1 and R2. Then this guy here will learn spoke 1 and spoke 2, spoke 1 and spoke 2. So they'll have full reachability with everybody, but they'll have to go through the jump back to the core, go from the core to the router, so on and so forth. It's your basic hub and spoke network design. So that's essentially what I'm reading through this and my understanding of how your network is built. This is what I'm seeing. So that I might not be correct, but this is essentially what I would infer based off of your explanation of your network. So iBGP is used to route propagate, and then spokes 1 and 2, when they propagate routes to the router, since there's no BGP to eIGRP redistribution on the router, then the core is going to learn those routes via iBGP. So that's essentially where that's going to come into play. Now, if you do propagation back and forth, so if we look at R1 and R2, they're going to get propagated via, so R1 and R2 will be learned via DEX, because the AD of 170 is better than the AD of 200. But however, spoke 1 and spoke 2 will be learned via 200. I can redraw that. So we have spoke 1 and spoke 2 will be an AD of 200, because there's no BGP to eIGRP on the router. Therefore, that's what the routing table probably looks like. That's my assumption based off of the information you told me. So, but you would need some sort of link between the core and the router to be able to exchange routing information. That's probably why that's there. And then, yeah, are you required to do iBGP? No, you could get away with eIGRP. eIGRP in the core makes a lot of sense, and BGP on the WAN, and that's totally doable. The only thing is, if you were to get rid of iBGP between the router and the core, you'd have to do, on here, you'd have to do BGP to eIGRP redistribution. Because you don't already have that there, you would need to add it in order for that to work. And then you add a little bit of complexity when you do that, because you'd have to make sure, I'm assuming that's not in play, that you wouldn't have the internet connecting to one of these sites. So let's say, for the sake of argument here, that this is the case, where you have one of your remote sites attached to your service provider core or service provider network also has a link to your internet and is also a spoke. So you would be learning routes from both. And you'd have to pick and choose which way you would go with that. So your core is your primary path, but your DMVPN hub is your backup path. So you'd have to be careful about dual connectivity on the remote side, so you don't get improper route feedback. But other than that, if that's not a concern, then that's essentially the way it's set up. Now, you did leave quite a bit of information here, so based off of what I don't really know why you worded it as by means of BGP regarding failover. So, actually, no, hold on one second. So actually, I take that back. So you said core switch primary WAN link and DMVPN is a backup. Okay, so you would have connectivity to both. So you'd have this guy here, this guy would also hook into here, then you'd also have this guy connecting to here, and then this guy connecting into here. I don't know why I didn't think about that the first time I read this, but you'd also have this. So you'd have internet and the service provider, or MPLS. You'd have internet and MPLS on the remote side, and you'd be learning eBGP both. And there's a very easy way to control that. And so to prevent route feedback is on this guy here, you just AS path prepend. You do you did prepend 100 twice. So this path right here would get an AS path of 100, 100, 100, and vice versa. So same thing on this green path. That's how you would do that. And on the remote side, if you wanted to make sure that it's you're controlling paths both direction, you would simply go on these routers and you would just do an LP towards the core. You just do a local preference. Local preference of, so for anything that's coming out of the service provider, on all these links right here, you would just do an LP of 200. And then they would all take the same egress path, and then if the SP network went away, or that link was lost, then you would automatically fail over to your internet. So that's all you would do. And that's why eBGP is such a great way of doing things, because then you'd have that flexibility. You can just AS path prepend over the eBGP peering, and do when you bring in the routes, any routes that are learned over the eBGP peering, you would simply be able to do an AS path or a loop local preference of higher on your MPLS path versus your so that's why it's set up that way. And then you would need some way to do route exchange. Now, what I would do, and probably one of the reasons why they're not doing BGP to eIGRP on the router, is to prevent some sort of routing loop. Maybe that was the case at some point, because if you do BGP to EIGRP redistribution, then they're both paths are going to be taking the EIGRP path between each other. They won't use the iBGP path because the AD would be lower. So if you don't do BGP to EIGRP redistribution on the router, then your router is going to only have a known path via iBGP, and you're going to choose to go the iBGP path across. So that's probably why they did that, and going along that flow. This is my interpretation. This is how I see your network, and if I was designing it, it's not a bad design. It gets the job done, and at the end of the day, these are one of the things that you would have to, if you haven't already done so, I would lab it up just to see what the variations are. This is a very common thing for people to do. So, is eBGP unorthodox, not uncommon? No, it's actually very widely deployed. But I would typically, depending on the design, I would more than likely do, I would probably go the path of least resistance. I'm EIGRP, and then you could do redistribution. But if you don't want to do, if you want to use BGP, eBGP is going to give you more flexibility, where iBGP, now I'm thinking about it, like if I was doing this and I had it peering iBGP from the router into a bunch of spokes, you're going to learn these routes via AD at 200, and they're going to be coming across the wire. So what would be your mechanism to choose one path over the other? Because you can't do you can't do AS path prepending. I probably would, if I was going to redistribute, I'd probably set the metric when I do redistribute into BGP from EIGRP. I would, when I do the EIGRP, redistribute EIGRP AS 100, I associate a metric to it to be higher on one path over the other, and the lower path. So the peering over the service provider, over this guy right here, I wouldn't do any metric weighting at all, and I would just let it come across as 0. And then on the over DMVPN, if it was iBGP for both, I would simply do a redistribute EIGRP 100 with a metric of 100 or something, just so that, when you do a multi-exit discriminator and you do a med lookup, you're always going to choose the path with the lower med. That's just how iBGP works. But eBGP gives you more flexibility, and I've seen a lot of customers do that. So hopefully that answers your question. I would lab it up if you have the ability to do so. This is not hard at all to lab up. You don't even have to make the service provider an actual legit MPLS core. You can just have 2 routers with some links attached to them, a handful of /24s, marry it up, build out what I did, use some loopback addresses on the remote sites and the spokes, do your route propagation, stand it all up, get it working the way that it's configured in your environment to mimic it. And I used to do this all the time for customer networks. I would literally log into their network. I would do a show run. I'd copy all the configs out so that I wouldn't accidentally be making config changes in their environment. And then I would have their configs pulled up. I would, after doing a bunch of discovery and having it all mapped out, then I would configure it all so that it would marry up to what I'm doing, so that it would be really, really easy to go through and understand how everything's put together. So that if you're making changes in the environment, you're making it in your lab and not on the actual hardware doing the network stuff. And you'd be able to know ahead of time if there's going to be a problem with something. So, and I discovered quite a few issues with routing designs by labbing things up and testing it out. Because, I don't care how long I've been a CCIE, you can't foresee every problem. You do your best to try to mitigate them, but that's why you test things out ahead of time. That's why the 80% rule is so important, especially in IT. If you're doing something, you want to make sure that you're putting a bunch of effort in first, so that when you actually are doing the rollout, you're not like, oh, I did not see that coming. You would want to be the guy that had already seen it and had been like, oh, and you're calling things out. And be like, oh, by the way, hey, I had this labbed up and then I ran into this caveat. And so this is the issue, and so I'm working on finding a solution for it. Or maybe you already had, and you're working towards mitigating that problem with some other mechanism. So some very interesting things to think about when you are starting to dig into how the network is put together and things like that. So that's why networking is so interesting, because there's not one way to put something together. And I would never say that there's one right way to do it either. It's whatever way meets the customer's business goals. That is the goal. And that is why there's so much flexibility out there in what we do. And, somebody might look at this and go, what in the heck am I looking at? Where I'm like, actually, it makes a lot of sense. Is there some weirdness? Sure. But once you take a few minutes and you dig into it and you think through the process, yeah, makes sense. And that's probably what they're doing. So they have that flexibility. They're probably doing AS path prepending and local preference, or maybe local preference and not AS path prepending, or vice versa, or whatever the case might be. So anyway, hopefully that answers your question. I have no problem answering questions like this if that's something you want to go do. Just specifically ask me to do it, and I will take the time to go through and answer your question. So, and I'm sure there's going to be somebody else in here that's it's like, I don't get it, and that's okay. And I can always deep dive into this type of stuff more, but these are interesting questions that people come across my desk with, and I'm like, oh well, let's take a look. Anyway, that is it for that. I'm a little late on posting the text or the Whiteboard Wednesday topic, which is going to be a deeper dive into specific architectures and things like that. We'll definitely talk about those things. And then again, for the coaching session on Friday, I'm going to leave it open. I'm actually working on somebody had asked a question. I'm going to go ahead and clear the screen since it's been up there for a while. Go ahead and clear the screen. So there's a question that was posted. When was it posted? Thought it was higher up. Thought it just came through. Let's see if I can't find it real quick. Oh, it was the same guy. Okay, so here's the question that came through the other day after the Whiteboard Wednesday. And there was a lot of detail. So actually, I don't want to cancel. All right, so let me go ahead and read more. All right, so this is literally could be its own whiteboard. YouTube Ask Me Anything, but I'm going to talk a little bit about this because it's something that I've been wanting to do, and I think it's a good thing for YouTube, and it takes the stuff off of the full long form videos of doing a dedicated series. So, will you consider to create some network content which is not bundled or bounded to specific certification like NA-NP-IE? I'll try to explain what I mean. There are a lot of certification related content out there. Well, I really like Cisco certification, but for me, it's always felt a bit disconnected from the real life, even though Cisco certifications is really best in networking industry. I think it would be really great if you can make some course about real life corporate networks. For example, some complex topologies, not only routers and switches, but also firewalls and load balancers. For example, I don't know where load balancers should fit into network and etc. So you can create such course with videos, several complex EVE topologies, workbooks, and of course, I'm not asking you to create such content for free. I'm willing to pay for such content, and I'm sure many people will be interested as well. Most of the technical content creators are focusing on certifications, and if you do such content, you will stand out. And it's a great idea. I definitely think that there's some merit to it. So and I'll continue because this guy has a lot of questions. So, um, real world network topologies, meaning different type of network design which you have seen during your career. How to plan from new site from zero. Choose correct design, correct equipment, how to plan subnets, etc. Different types of network migrations. How to plan migration to the office network, for example, from one physical location to another with minimal downtime. Migration from one routing protocol to another, OSPF to iGRP with minimal downtime. Migration from one WAN technology to another, for example, MPLS to DMVPN or vice versa. Other network migration which you can think of. How to properly plan maintenance window for change in the network. Load balancers. He basically just covered that one. Firewalls. Depending on what firewall should be placed before or after or in parallel. By parallel, I mean the design where the firewall is connected to the core switch, where the default gateway to firewall, and then there is WAN block with routers. DMZ zone. How they should be designed, which policy should be configured on firewalls, third-party company connectivity to the corporate firewall, site-to-site VPNs. Example, company B needs to get access to some resources of company A and vice versa. And for that reason, site-to-site VPN is configured. How to properly and securely configure such tunnel, which policies should be configured. How to correctly publish public servers on firewall, for example, web servers. There are a lot of materials about routing protocols out there, but there are not a lot of materials about how to optimize routing protocols. For example, when and how hello times of eIGRP and OSPF should be tuned, etc. BFD, in which situation we should use it to minimize routing downtime, etc. Network monitoring, logging. There's a lot, and there's a lot more. I think he might have ran out of actual options here. Common best practice configuration, what to do with native VLAN, when we need to configure broadcast storm, and how to do it properly. Some useful initial config examples of routers and switches, and any other best practice configs from your experience. Configuration of AAA, like Cisco ICE, to authenticate network devices. So he's talking about TACAX and Radius. I think it's possible to use ICE and VM and EVE. A data center portion network. Configure VXLAN, OTB, or any such type of technology. Routing between corporate network and public and or private cloud. Some notes. I'm not interested in SD-WAN and SDA because I don't have them. So if you could make that course for classic LAN, WAN technologies, I'd be really happy. Anyways, it's not possible to emulate SD access, I think, like eBNG, and it will be just easy to make such course classic LAN WAN and more efficient, because I think most people would be interested in classic LAN and WAN technologies. Cisco routers and switches are the most popular, and from my point of view, they're really the best. Of course, it makes sense to use Cisco images for the lab topologies of the course. Cisco has the best choice of virtualization images. As for virtual firewalls, I would prefer you to go with Palo because it's more trending than Cisco or ASA or Firepower. Anyway, there are many virtual images to different firewalls to choose from, but my advice for the course would be to use firewalls which you have the most experience with. Okay, so that's a lot. That is a lot. But there's a lot of really good ideas. So I gave some thought, and I actually sat down over the weekend, and I put some thought into this, and it's a big topology. And it's going to take me some time to put it together. So let me see if I can't. Is it this guy? It is this guy. So I think Ali, however you say your name, I'm going to say it's Ali K. I'm going to assume that's what it is. Let me pull this up. Okay. So this is the big topology, and it is it's a work in progress. So I don't have any load balancers in there yet because I honestly don't have any load balancers to play with, other than the ones that you get from the advanced load balancer that works with NSX. So this is what I'm playing with. Let me open this up. It's a monster lab. Maybe this is what you had in mind. Maybe it isn't. But it's what I was kicking around over the weekend. So this is what I came up with. It's a work in progress. So I'm going to go ahead and show you just for the simple fact that it's got potential, but then again, maybe not. We'll have to figure that out. So let me go ahead and zoom out a little bit. This thing is a beast. This took me every bit of about a day to map out. So the whole point of this thing, it's not powered up, and I would never expect anybody to power something this big up unless you're on a dedicated server. And this is running Eve Pro on a dedicated Dell server. I haven't booted anything up yet because I'm still playing around with the idea. And my goal here was to show you guys a topology, and I'm gonna make sure you guys watch to the end of the video, because if this is what you guys have in mind for size and complexity, I can build something like this. It's going to take some time. There would be it would be a breakdown of how things work in a particular given set of scenarios. So there would be your like for example, the DMVPN and other questions that you had. I could 100% demo that. So for example, there's no reason that I couldn't. Normally I would put a router in that place, but there's no reason why I couldn't mimic that and say, here we do eBGP, and then we do eBGP here, or we do some sort of peering here, but then this guy's our DMVPN hub. This guy right here is running all of our dynamic routing. This is our core. Nothing says I couldn't mimic that. I can make some stuff happen and then walk you through why you would do certain things. So we have a pretty aggressively sized core, our HQ site. I've got quite a few with the intention of doing some DMZ type stuff, where you'd hit this firewall and then you'd be able to access things internally if you wanted to, or you would hit these guys. And my attempt here would be to try to do things like ASA clustering, because I know that's on the. I look at the security blueprint, that's still there. I'll go over that here in just a minute. But I have Palo on the edge. I've got FTD in place here. So it would be a mixture of things: firewall, routing, all that type of stuff. You'd have some internet routing, so on and so forth. Some XR, some iOS, some CSR 1000V. So you get iOS and XE. You get a bunch of firewall connections and sites with big circuits and connectivity and things like that. So if this is something that you are interested in seeing, and VXLAN eVPN with, I have one connection that's connecting from the outside, so these top 9Ks would be your border switch, so you would come in via routing, but we would do 25 and 31 would be our border gateways to do multi-site VXLAN eVPN. We would have spokes attached to the MPLS core doing both layer 2 and layer 3 VPN, so on and so forth. So it's giving me a lot of flexibility. Maybe it makes more sense to hang a switch off PA2 and 3 and FTD7 so that we can do some DMZ type stuff. There's some room here, and I'm not locked in here. It's as clean as I can get it with what I've got deployed so far. But I want you guys to let me know down in the comments if this is something that you would actually be interested in, because it's going to take some time to stand this up, and it's going to take some effort to go through all of this stuff. It's almost like doing the CCIE enterprise lab that I did several months ago, where I walked you through how to configure a bunch of stuff. So I've got no problem doing this and the migration process and things like that, but I don't know what you guys want to see, and when it comes to doing something like this. So there will be some learning from my part, because I've never actually configured ASA clustering, so I'd have to go watch some videos, maybe look at some configuration guides. But as far as I know, if I look at here at, they have, I don't know if clustering's here, ASA and FTD, route single, multi-context, multi-instance. I don't know if they're going to actually use the term cluster. High availability. Oh, it is right there. So clustering and high availability features in ASA and FTD. So I would probably have to go through and learn how to do clustering because it's on the security blueprint and things like that that goes along with it. So, and there's nothing says that with the way that this is set up, I don't have any ASAs here, but I could probably throw an ASAV in here, and or maybe in the maybe I make this a colo. Maybe I attach an ASA to one of these switches and have it connect to the MPLS provider or the internet, or maybe I have some of this room that's out here and I make this a colo, and if you're a PC out here, you're a home user, and then you vet the VPN to the ASA, and then the ASA has routing of maybe a site-to-site VPN, for example, and a site-to-site VPN to the FTD or the Palos, and we have to do remote access connectivity. So there's lots of options. Maybe this is my colo. Maybe that's what I do. Maybe that's my colo facility, and maybe I build another one out here that connects to these guys. It's private WAN, or I do it up here where there's both private WAN and internet. I don't know. Maybe again, there's lots of options. I just haven't figured out what the best way of going about this is. So these are some things that if you guys are interested in seeing this, let me know in the comments, and I will start to put together a thing. Now, I don't think this would be book worthy. Maybe it will, but it's really one of those things going based off of your questions and your comments. There's a lot. What I could do is, let's go ahead and look at this. What I could do is I could maybe put this into in an order and make it like architectures and standing things up, a migration. Maybe we have something already in place. Maintenance window, how we're going to stand this up, how we're going to stand that up, how we're going to migrate this, how we're going to migrate that. Maybe I take your list of bullet points and figure out what to do with those things, and how we can get them configured appropriately where we need them to be. So that's kind of where I'm thinking about going with this course, and it would be titled Real World Networking. And the idea would be the more feedback I get from you guys as to whether or not this needs to be broken down, add more things added to it, whatever the case might be, these are things that I would need to know about. Because, if you take into consideration, for example, if I was to say, you guys like the idea of the colo, for example, and I'm like, okay, maybe I move this link over to here, and then I swing this guy over here, but then I have a colo facility where I put a couple firewalls, or I put a firewall in a colo that's got both internet and layer 3 VPN peering connectivity to it. And then I just configure that out. So to give you an example of what I mean by that, if I go here and I delete this link, and then I move this link to here, it's running a little slow because of how big it is. That's why, in case anybody was wondering. So an ASAV would allow me to run any connect. So let's just say, for example, I did that. So we're going to move these guys over to here, right? So that's my connectivity there. And then maybe I do something like this, where I have an ASAV. And for the out of the gate, I run 1. So we're going to put in here, we'll put in 2 just because of the fact that it gives me the number. And we're going to say, we'll put in here firewall. And we'll do 8 ports, that's fine. But we'll do telnet connection. Yep, that works. Where'd they come in? I don't see them hanging out anywhere. Oh, there they are. So we move this guy here and this guy here. Okay, so we do this, and then we grab another switch. We grab, we'll say 2 switches, because you need two. We'll do that. We'll say save. Okay, so they're moved out here. Okay, so we'll move them to here. Then what we're going to go do, we're going to zoom in. Oops. So what we're going to do is we're going to have this guy come in here. And we'll have, actually we'll need it both ways. So we'll need this guy here. We'll handle some things. And then we'll have this guy here. We'll handle some things. Okay, so what we'll do is we'll run a link between the two. And the idea here would be to run HA, but we wouldn't have to run that right away, right? We would, but we could get it working because I don't think I've ever done HA firewalls doing any connect. So I don't know if there's any caveats with that. So, but what we'll need is connections to here for the inside, or for the outside, excuse me. We'll save that real quick. So the whole connectivity thing here will be, and I'll explain this here in just a moment once I get it all wired up. So the idea would be you would come in on, say, gig 1, right, from the outside world, whether you're coming in from the internet or you're coming in from the private WAN, whatever the case might be. It makes more, the private WAN kind of doesn't make sense in a certain way, but it does if you think about it. So we're going to draw a link from here to here. We'll let that come in, and then we're going to connect switch 36 down to the router down here at the bottom. And then we're going to line this guy up to here, like that. So this would be the coming into the firewall from the outside. Or maybe we hairpin it. Actually, no, now I'm thinking about it, that makes more sense. So we would come in over the internet, and we can even add an additional link here for high availability. We'll do that instead. That makes more sense. Because it doesn't make sense really to come in over the WAN because you're already private. So, real world, right? That was the logic here. So let's move this guy over here just a little bit. Okay, and then we're going to get rid of switch 39. We'll go ahead and delete that guy. All right, so the idea here would be you'd use the switch to do 2 VLANs. You'd put say the even numbered VLANs, or sorry, the even numbered ports, gig 00 and gig 02. They would go into VLAN 10, and then the odd numbered ports 10 and 01 would go into VLAN 11, connecting to 63. And what you would do is you would have sub interfaces on each one of these guys. And the idea, actually, I probably would need to do the switch. I would. To come into the back end of the MPLS, actually, I can't undo it now that I've done it. So I'll have to go ahead and I'll rename this switch 139 just so that it's there. So we'll say this here. We'll say switch 139. We'll save that. And then we're going to bring him over here. And then we'll connect him there like so. And that'll allow us to have our traffic come in from the outside, hit the VPN, and then from the VPN route internally. That's what we'll do. And then that'll allow us to connect into the remote side. Hopefully that makes sense. And for the sake of argument, I'm going to say no, it doesn't, just for those that are like, I don't know. Hopefully I have enough ports on that router. I think I did. Yes, I do. So essentially what I mean, and just one of those things where it wasn't until you brought up remote access VPN that I thought about it. So essentially what I mean by this is, let's say, for example, I'm PC99 and I'm a home user and I have a Palo firewall sitting at home. And I need to VPN into the corporate network. Okay, so I go out the firewall, I jump across the internet, I come in here, I landed on firewall 136, I VPN'd in. Okay, now I'm here, and now what I need to go do is I need to come in, jump in here to go to, say, something up over here. That is the point. That's what the routing would do. So you would have it set up to where you would allow connectivity into your your fabric into your connectivity, and you'd have two different ways to get in. So I could either like get rid of this peering here. I probably would do that. Is you could do two switches in a stack and have one as your internet circuits coming in, and then you have your other switch is your internal connectivity. Same switch, two different three or four different VLANs or whatever you want to break it up as. So you could totally do that too. So for the sake of argument, I'm going to go ahead and clear this off, and I'm going to go ahead and get rid of this link here. I don't need that one. And because I don't need that link, I'm going to go ahead and move this one back to gig 6. I'll just update that real quick. That'll be an easy fix. So, but Rob, what if I wanted to go through and do connection from switch 139 to R46? You can do that. You could totally peer it. Maybe there's multiple PE peerings into your colo. And let's say this is a colo. I actually hadn't thought of that until literally I was walking you guys through what it looked like, and I saw his comment about remote access VPNs. So anyway, that's essentially what I'm thinking for this topology and for this set of videos. That would be your colo. For you to bring in remote access connectivity, it connects into the colo, and everybody's happy. So, this theoretically could be down here, and you just bring an internet circuit in, but, you guys get the point. And if you guys have questions, drop it in the comments. If you guys like the idea, give it a thumbs up, comment, I'd like to see this, or whatever, so that I know it's worth the time and effort. Anyway, that's a long video. Thank you guys for stopping by and hanging out with me, and I'll catch all of you guys in the next one.